Enterprise Data Center Design Considerations. This section describes general enterprise data center design considerations and provides an overview of the general technologies and models used in an enterprise data center. Server-centric to service-centric. So this server-centric data center model is evolving into a service-centric model. Well, the evolution includes the deployment of the virtual machine software, such as a VMware and Xen, which breaks the one-to-one relationship between the applications and the server hardware and operating systems on which they run. So virtual machine software allows multiple applications to run on a single server, independent of each other and of the underlying operating system. So the removal of storage from the server, consolidating it in a storage pools, so network storage such as the SAN, or the storage area networks, allows easier management, provisioning, improved utilization, and consistent recovery practices. So the creation of pools of one-way, two-way, or four-way servers that can be pooled and provisioned on demand. So the consolidation of the I/O resources so that the I/O can be pooled and provisioned on demand for connectivity to other servers, storage, and LAN pools. The Cisco Enterprise Data Center Architecture Framework. So the consolidation and virtualization of data center resources requires highly scalable, resilient, secure data center network foundation. So as described in the previous video, applying methodology to a network design, the Cisco SONA, or the Service-Oriented Network Architecture Framework, defines how enterprises can evolve towards intelligence in the network that optimizes applications, business processes, and resources. So the Cisco Enterprise Data Center Architecture, based on SONA, provides organizations with framework to address immediate data center demands for consolidation and business continuance while enabling emergence, virtualization, and on-demand computing technologies in the data center. So this Cisco Enterprise Data Center Architecture, as illustrated on this diagram here, aligns data center resources with business applications and provides multiple resources to end users in an enterprise. So the Cisco Enterprise Data Center Architecture has the following layers. So basically, you'll have there the network infrastructure layer. So meets all the bandwidth, latency, and protocol requirements for user to server, server to server, and server to storage connectivity, and communications in a modular hierarchical structure. So the next one would be the interactive services layer, so which provides hierarchical infrastructure services that ensure the fast and secure alignment of resources with application requirements, and Cisco Application Networking Services, or ANS, that optimize application integration and the delivery of applications to end users. Let's have an example. This is a data center network topology. This illustrates a sample high-performance data center network topology that requires many technologies and connectivity options among applications and data centers. So this network topology provides connectivity services for network elements within the data center, such as servers and storage, as well as to external users or other data centers. Enterprise Data Center Infrastructure Overview. So this figure here shows a typical large enterprise data center infrastructure design. So the design follows the multi-layer infrastructure architecture, including the core, aggregation, and access layers. So you've got core, aggregation, and of course, our access layer here. Now, the data center infrastructure must provide port density and layer 2 and layer 3 connectivity for servers at the access layer while supporting security services provided by access lists or ACLs, firewalls, IPS, okay, at the data center aggregation layer. It must support server farm services such as content switching, caching, and secure socket layer or the SSL. Okay, so well, that secure socket layer is basically used in the web access, offloading while integrating with a multi-tier server farms, mainframes, and mainframe services. Okay, so with load balancing and SSL offloading. Now, network devices are often deployed in redundant pairs to avoid a single point of failure. So if you will observe, you've got redundancy among connectivity, you've got aggregation on this part here, okay, on the data center aggregation. You also have link aggregation on the data center core, and you have some sort of redundancy. Data center access layer. So what do we have here? So the data center access layer provides layer 2, layer 3, and mainframe connectivity. The design of the data center access layer varies depending on whether layer 2 or layer 3 access switches are used. So it is typically built with high performance, low latency layer 2 switches, allowing better sharing of service devices across multiple servers, and allowing the use of the layer 2 clustering, which requires the server to be a layer 2 adjacent. So with layer 2 access switches, the default gateway for the servers cannot be configured at the access or aggregation layer. So servers can be single or dual attached. Okay, so with dual attached NICs in the server, a VLAN or trunk is required between the two redundant access layer switches to support having a single IP address on the two server links to two separate switches. So the default gateway is implemented at the access layer, a mix of both layer 2 and layer 3 access switches using one rack unit or one RU, okay, and modular platforms in a flexible solution, and allows application environments to be optimally positioned. Density and scalability implications. So some scaling issues in the data center relate to physical environment. The typical enterprise data center experiences high growth in the sheer number of servers. At the same time, server density has been improved with one RU and blade server solutions. So three particular challenges result from this trend. So you've got the cabling, okay, or cable bulk. Typically, 3 to 4 interfaces are connected on a server with a higher density of servers per rack. So cable routing and management can become quite difficult. Next would be power. So the increased density of components in a rack is driving a need for a larger power feed to the rack. So many data centers do not have the power capacity at the server rows to support this increase. And the last one is cooling system or the cooling. The number of cables lying under and raised floor and the cable bulk at the cabinet base entry is blocking the airflow required to cool the equipment in the racks. So at the same time, the servers in the rack require more cooling volume because of their high density. So basically, these challenges have forced the customers to find alternative solutions by spacing cabinets, modifying cable routes, and other means, including not deploying high-density server solutions. Defining the data center aggregation layer. So the data center aggregation or distribution layer aggregates the uplinks from the access layer, okay, to the data center core layer and is the critical point for control and application services. So security and applications such as load balancing devices, SSL offloading devices, firewalls, IPS. So that provides layer 4 through layer 7 services and are often deployed as module in the aggregation layer. Okay, like service modules here. Now, this highly flexible design takes advantage of the economies of scale by lowering the total cost of ownership or TCO and reducing complexity by reducing the number of components to configure and manage. So service devices deployed at the aggregation layer are shared among all the servers, whereas service devices deployed at the access layer benefit only the servers that are directly attached to the specific access switch. Defining the data center core layer. So implementing a data center core layer is a best practice for large data centers. So the following should be taken into consideration when determining whether the core is appropriate. So first, you've got a 10 gigabit Ethernet port density. So without a data center core, will there be enough 10 GB Ethernet ports on the campus core switch paired to support both the campus building distribution layer and then the data center aggregation layer? Next would be the administrative domains and policies. So separate campus and data center cores help isolate the campus building distribution layers from data center aggregation layers for troubleshooting, maintenance, administration, and implementation of policies using the quality of service and access lists. Next would be anticipation of the future development. So the impact that could result from implementing a separate data center core layer at a later date, okay, or at a later date might make it worthwhile to install it at the beginning. So the data center typically connects to the campus core using a layer 3 links, okay? The data center network addresses are summarized into the campus core, and the campus core injects a default route into the data center network. So key data center core layer characteristics includes the following. Okay, so you've got the distributed forwarding architecture, low latency switching, 10 GB Ethernet scalability, and scalable IP multicast support. So to summarize the enterprise data center design considerations, so enterprise data centers support a rich set of applications and servers. So the SONA-based Cisco Enterprise Data Center architecture provides a modular hierarchical approach to align data center resources with small business applications. So the enterprise campus and data center design review. So analyze the organizational requirements. So type of applications, traffic volume, and traffic patterns. So redundancy and backup will be needed. Okay, so you have the options like different protocols used for redundancy. Characterize the existing network and sites. So technology used and location of hosts, servers, terminals, and other end nodes. Develop enterprise campus and enterprise data center network designs. So based on requirements, implement 2 or 3 hierarchical layers. So select the hardware and software components to support requirements. Now, to summarize the entire module, the campus network design is influenced by application, environmental, and infrastructure device characteristics. An enterprise campus network is conducted hierarchically with building access, building distribution, and campus core layers. An enterprise data center network is constructed hierarchically with data center access, data center aggregation, and data center core layers. That's the end of this video. I hope you have learned something from this. Thank you and see you on the next video. Have a great day.